What's up YouTube, this is Demkeys back again with another Unity tutorial, and today I will be teaching you about the wheel collider. The wheel collider is a special collider for grounded vehicles. It has built-in collision detection, wheel physics, and a slip-based tire friction model. It can be used for objects other than wheels, but it is specifically designed for vehicles with wheels. So let's begin. What we have here is a terrain, a camera, and a directional light that you cannot see because I have disabled it from the gizmo. The first thing we need to do is create a cube, and I'm going to stretch this out a little bit so that it kind of resembles our car body. Okay, I think that's good. Next we need to create, before that let's rename this object. I'm calling it car container. Now within car container you have to create an empty child and call it wheel colliders. Now one thing you need to remember is that your wheel collider is not the same as the actual wheel, like the 3D model of the wheel, because well, it's just not the same. You would have your wheel colliders in different objects and under this separate child, and then you would create a separate child for your wheel graphics or your wheel 3D model, whatever. Okay, so within this I'm going to create another empty child and call this, well, let's not rename this right now. First let's add the wheel collider. Now under the wheel collider component you can see all these properties. I'll explain these shortly. I think now we can duplicate this collider, this object. Okay, so as you can see, this collider is currently placed in the middle of our car container. So I'm going to change its location and then rename it accordingly. Let's call this wheel call FL. So that's wheel collider front left. Okay, I guess I should make the copies now. I'll make a duplicate and place it here. I'll call this wheel call RL, as in rear left. And then we can just duplicate these two together, and I'll rename this to, yeah, front right, and this one to rear right. Next I'm going to place our main camera within the car container and change its position. So now the camera will follow the car wherever it goes. Okay, so let's take a look at these properties. First you have mass. Mass is how heavy the wheel collider is. So you can actually add weight to your wheels for whatever reason you might want to do that. Next you have radius. This is the actual size of the collider. You can see it increasing as I change the values. I'm going to set this to, I think 1 is perfect. Yeah, I think 1 is fine. If we need to change it later, we can change it. Next we have suspension distance. Suspension distance is the maximum extension distance of wheel suspension measured in local space. Suspension always extends downwards through the local y-axis. So if I increase this value, you'll see the suspension extending down over here. It doesn't extend upwards, it extends downwards. I can set this to 0.8 or let's say 6. No, 8 will be better. Alright, next we have center. This is the center of the wheel in the object's local space. This is pretty much just moving the collider around within the actual object. So the collider is within this game object and we can move it around if we want. I don't need to, so I'm just going to leave it at 0. Next, suspension spring. Basically, the suspension attempts to reach a target position by adding spring and damping forces. That would be the spring and the damper. Okay, what is spring? Spring forces attempt to reach the target position. A larger value makes the suspension reach the target position faster. Next, we have damper. This dampens the suspension velocity. A larger value will make the suspension spring move slower. This can be very useful when you don't want your car to be really bouncy. Next, target position. The suspension's rest distance along suspension distance. Suspension distance is this and target position uses this value to calculate what the target position will actually be, like the minimum and maximum. Okay, so 0 maps to a fully extended suspension and 1 maps to a fully compressed suspension. You'll see this working shortly as well. We are going to set this to 0. Next you have forward friction and sideways friction. Now both these friction models work on something called a wheel friction curve, and I tried my best to understand this but I couldn't. It's a little too complicated for me. What I did understand, however, and what many people on the internet are suggesting, is that you just change the stiffness factor, and this does work. So if I change this to 0.02, the car won't instantly start moving. When I apply force to the wheels, then they'll spin. I'm going to change this back to 1, and we will be playing around with sideways friction because you can actually see the effect in that. The last thing to do is add a rigid body. Now because you're building a vehicle, so you might want to simulate realistic properties, like for example the weight. I'll set this to 2000 and then I will apply the forces based on that. I think this was 0.8. Yeah. Okay, so spring. We'll set this to 11,000 and this is affecting all 4 colliders. Damper. We'll set this to 400 and target position is 0. So I'm going to run the game and let's see what happens. Okay, maybe I should place the car a little higher. So as you can see, the car falls down and then the suspension actually comes into action. So the car bounces and then the damping or the damper stops the springs from, I guess you would say, bouncing too much, over bouncing, whatever. Let me show you what happens when you set damper to 0. You see the ride becomes really bouncy. If I set this to 400, there's more stability in it. It doesn't bounce so much. Okay, so I'm going to change the value of spring now. Wait, it's better if I change it during runtime. So it's currently 11,000. And notice this height over here. I'm going to change 11,000 to 5,000. And the car starts to move down. This is because the amount of force being applied to the spring is not enough, and so the car goes down. Alright, now let's add a script to our car so that we can actually move it around. We'll call this car movement script. So the first variable that we'll add is a public float motor force. Next we have to create 4 wheel collider variables and name them accordingly. Alright, so if you want to actually move your vehicle, there are 2 ways that you can do it. One, apply force to the rigid body itself. 2, apply force to the wheel collider. So we are going to apply force to the wheel collider. The way to do that is to increase the motor torque value. Okay, so first float V equals input.getAxis vertical into motor force. Next we'll call RL dot motor torque equals V, and the same thing for the rear right collider. The reason why I'm applying this to only the rear colliders is because I want it to be a rear wheel drive. If you want it to be a front wheel drive, you can apply it to only the front wheels, or if you want it to be a 4x4 or all wheel drive, then it's just apply it accordingly. Okay, so what's gonna happen now is input.getAxis is going to get whether it's going to tell us whether we are pressing W or S, or the arrow keys up or down, and it will return a value between -1 and +1, and then it will multiply that value with motor force. So if we are not pressing anything, then V is going to be equal to 0, and then there won't be any torque being applied. Okay, so let's test this out, see if it's working. Before that, we have to place the appropriate colliders in these variables. So that's front right, then front left, rear right, and rear left. And we can apply a force of, say, 30. Okay, now let's see if how this car behaves. Oops. So as you can see, the car is able to go forward and reverse. Next, we need to work on steering the car. So for that, we're going to need to turn the collider. First, let's create a public float variable called steer force. Next, float h, and this is going to work the same way how float v is working. Next, we need to apply this steer force. In fact, we need to apply the value of h to both of our front colliders. So we'll call fl.steer_angle equals h, and the same for fr. Now let's see if this works. Before playing the game, we need to enter a value for steer force. This is actually steer angle, but yeah, it's okay. As you can see, currently the wheels are just facing forward. Oops, I got the wrong variable. Okay, so there seems to be a mix-up with the collider names, I think, or I must have placed them wrong. Uh, I'm not sure. Let's see. Okay, rear left is rear left. Then rear right is in the front, so that is wrong. We need to change its name to front right, and then change front right to rear right. So is it correct now? No, we need to change it over here as well. So rear right goes here and front right goes here. Let's see if it works. Yes, it does. As you can see, the wheels are turning, and this actually does make our vehicle turn as well. We can drive this vehicle around our track. Okay, so you just saw the car flipping. This happened because of body roll. Basically, it's physics. When the car is moving and you turn it, then a lot of the body's weight will be applied to one side, and that depends which direction you're turning the car to. The weight will be applied accordingly, and so there is a chance for the body to flip. The solution to this problem is to add a sway bar or an anti-roll bar. This basically transfers some of the, I guess it transfers some of the force or some of the weight being applied to one side, and so there's not as much weight being applied to that side, and so there's less chance for the body to flip. Unfortunately, I cannot show you how to make it, but an excellent example of this would be in Eddie's vehicle physics engine. He has applied this concept and it works very well. I'm going to post a link to Eddie's website and you can check out his physics engine over there. It's also for sale, so if you would like to buy it, then you can. Okay, I'm going to change the suspension distance to 0.6, make it a little shorter, so that gives our car a lesser chance of flipping. Well, uh, the difference is very less. It's not all that much, but yeah, it should do for this example. Also, similarly, you can apply uh, friction. You can basically make the wheels slip if you don't want the body to start rolling. Change I'll change the value, I'll change the sideways friction of, I'll change the I'll change the stiffness factor of the front wheels to 0.08, I guess, and rear wheels to 0.02. Now let's see how much this helps. As you can see, the car is actually drifting, but then after a certain point it flips because that has its limits as well. Like I said, you need a sway bar. Okay, next we need to apply brakes to the car so it can stop. The way to do this is to apply brake torque. First, let's create a public float variable called brake force, and this is what we are going to apply to our wheels in order to make the vehicle stop. So if the space bar is pressed, then we want to apply the brake torque to both the rear wheels. Also, once the spacebar is released, then we want to change the brake torque back to 0, because once it is set to a certain value, if you don't change it, then well, the brake will still be applied and you cannot that wheel is not going to spin. Now let's apply this value, sorry, let's set the value. I guess 30 is fine. Keep in mind this brake is only being applied to the rear wheels, not to the front wheels, so your car will behave accordingly. Well, there's also drift, so I need to change that. But yeah, you can also see how sideways friction is working. Hold on. Change all this back to 1. So the vehicle stops. Apparently the amount of force being applied is less. Maybe I should increase it to say 40. You can apply whatever value you want and the effect will be according to that. Okay, don't go too high because otherwise you're gonna get weird results. Like, let's change this value to 150. You see how the front comes up? So, well, that's not necessarily a bad thing, but then it can give you unexpected results. So be sure to set the brake torque, or in this case, brake force, according to the setup of your car. Alright, so the wheel collider class has a built-in function called get ground hit. This gets the ground collision data for the wheel. You can use this in cases where, well, there are many scenarios where you can use it. One of them would be, for example, you're driving on the road and suddenly you go off-road, so you're driving in the sand. So you might want your tires to behave different. They might have less grip or whatever. So we are going to use this now, and I'll show you a couple of examples. Okay, uh, get ground hit takes one parameter, which is a wheel hit parameter, just like how physics.raycast takes raycast hit. This has wheel hit. So we'll create two variables, wheel hit rear left and wheel hit rear right. Next, if wheel call rl dot get ground hit out hit sorry out hit rl, that basically means that if the vehicle is touching the ground or colliding with the ground, then this is going to return true, in which case this if condition will execute. Okay, so what do we want to do in that case? Mm, let's display uh, okay, if hit rl dot collider dot game object dot tag equals, say, finish, then debug.log car is on pavement. And we'll make one for the rear right wheel as well. Well, actually we don't need to. I mean, it's an example and you'll understand with just one. So what's gonna happen here is the rear left wheel collider If that collider is actually touching an object that has the tag finish, then debug.log will show this. Okay, so let's create a pavement over here. It's just going to be a regular cube, and I'll stretch it, make it a little flat. Yeah, I think this is okay. Set its tag to finish, and now let's run the game. So currently nothing is showing up on the console. Now the front left wheel is on the cube, so nothing is showing up on the console. Okay. Oops. Forgot to save the script. Okay. So now the front right collider is on. It's on the cube, and nothing is showing up in the console. As you can see, as soon as the rear left collider comes onto the cube, there are many debug.logs being shown, because this is all happening within the update method. So let's try that again. Notice this number over here, because you won't be able to notice over here. You can see this number increasing. My collider is still on the cube, and so it's just going to continue increasing. Once I take the collider off, it stops. So this is, like I said, it's one use of it would be to find out which terrain the car is actually on. And let's see another example. Okay, let's show the force being applied to, no, not the force, the tire slip. Yeah, this is going to show us the tire slip in sideways direction. Let's create a public float variable for okay, sideways slip rear left, and then rear right. Okay, so once I run the game, whatever the tire slip of rear left and rear right is, those values will be shown over here. Now I'm not sure if this is exactly how it how the tire smoke is shown, but you could use it for this purpose. Like you can, if if the tire slip goes past a certain value, then you can start showing a particle effect of some sort of smoke. So that's basically showing that the tire is slipping. Also, let's change the values of rear right and rear left to 0.08, so the tire actually slips. Only then you'll see this value changing. Oh, just a minute. I should also change this, the front left and front right, because otherwise the car is going to flip. Okay, this should be 0.02. That's the rear tires. So you can see the value over here. You can see as the car is slipping, the value is becoming higher. Wheel hit has other variables that you can access as well. Check it out, there's a couple of them. I guess that's it. This is how you use the wheel collider. I hope this tutorial was helpful. Do check out these other videos as well. The video on the top left teaches you about Unity's navigation system. The video on the top right teaches you about the particle system, and the video on the bottom left teaches you a game mechanic called run, jump and spin. I'm also accepting donations, so if you would like to help me out, you can send your donations to my PayPal email address mentioned on the screen and in the description below. Don't forget to like, share and subscribe. Leave your comments below, and I'll see you guys next time.
Is he even still the same? Claiming Lord's boys, but we never seen him main. Out on cover, now on album when he get the chance to hang. Like, damn, 134. Niggas acting like I never been through them doors. Moved uptown and I rocked a little red. Niggas asking if I'm raw cause I'm out in Hempstead. Like, shit, who are you? Entourage member or